Welcome to the Walton Pi. Today we're going to go through some examples of using the product rule. Alright, to get started, let's just do a fairly straightforward product rule. Let's take the derivative of x cubed e to the x. So remember, the product rule says that if we have f times g, that's going to go to the derivative of the first times the second plus the first times the derivative of the second. That's what the product rule says. So the derivative of this is going to be equal to the derivative of the first, in this case the derivative of x cubed, so that's just 3x squared from the power rule, times g, so our second function is just e to the x, plus our first function, x cubed, times the derivative of the second function, or derivative of e to the x is just e to the x. So the derivative of this is going to be e to the x times 3x squared plus x cubed. That's the derivative of that function. Let's say that we are now trying to figure out what is the derivative with respect to x of x cubed minus 4x plus e to the x times, let's say, times x squared plus 2. Well, f times g is going to go derivative of first times the second plus the first times the derivative of the second. So this is going to be derivative of the first, so x cubed minus 4x plus e to the x prime times x squared plus 2, plus the first, x cubed minus 4x plus e to the x, times the derivative of the second, x squared plus 2 prime. Well, the derivative of the first one, that's going to be 3x squared minus 4 plus e to the x. That stays the same. This one also will stay the same. And then this one becomes a 2x. And so that's going to be the derivative of that function. Now, it could get a little bit more complicated if suppose we're taking the derivative. Here, let's say instead that f of x is equal to x squared plus 3x times e to the x plus 4 x to the fifth times x squared minus 2x minus 7. Here we have three functions all multiplied together. So what we're going to do is we have to clump this up into two pieces so we can use the product rule. So I am just going to clump them like this. So we are going to clump the last two together as one function. So we can say that f prime of x is going to be first times the derivative of the second, so x squared plus 3x, times that whole thing prime, so that's going to be the e to the x plus 4x to the fifth times x squared minus 2x minus 7 prime, plus the first one prime, x squared plus 3x prime, times the entire second one, which in this case is not going to be taken the derivative of, so e to the x plus 4x to the fifth times x squared minus 2x minus 7. Perfect. So most of this is going to be able to be evaluated already, except for this piece. Here we're taking the derivative of two things multiplied together. So that means that piece itself is also going to have a product rule. So we can expand this piece out into first times the derivative of the second. So that piece is going to be e to the x plus 4x to the fifth, first times the derivative of the second, the derivative of x squared minus 2x minus 7 prime, plus the derivative of the first, e to the x plus 4x to the fifth prime, times the second, x squared minus 2x minus 7. So that is what that whole piece expands into. And then the rest of it we can just stick on to the end. So we have an x squared plus 3x here. And then we have our plus x squared plus 3x prime e to the x plus 4x to the fifth x squared minus 2x minus 7. And so at this point we can start to evaluate the different pieces. So we're going to get x squared plus 3x times e to the x plus 4x to the fifth times 2x minus 2 plus x squared plus 3x times the derivative of e to the x plus 4x to the fifth, so that's an e to the x plus 20x to the fourth, times x squared minus 2x minus 7, plus derivative of x squared plus 3x, that is 2x plus 3, times e to the x plus 4x to the fifth, times x squared minus 2x minus 7. So this whole long thing is the derivative of f of x. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.